So I'm talking about ecosystem services, which gives you a bit of a context, moving away just from seeing the carbon perspective or the BVOC perspective to including the wider picture. So since my talk is also split today and tomorrow a bit, that's a short outline. So I will first give you a definition and classification of the concept and give you a brief overview why it helps us. Then we will talk about how ecosystem quantities are assessed. Then the economic perspective of the concept, if we should put a price tag on our systems. The relationship between ecosystem services, so trade-offs and synergies, and that actually leads you to the practical session today. And then we make a break with this lecture. And tomorrow we will talk about common trade-offs, and I will also give you some examples of trade-off analyses. So starting with the definition, although there is no universal classification of ecosystem services, the mostly cited explanation comes from the Millennium Ecosystem Assessment. And that is that ecosystem services are the benefits that people obtain from ecosystems. And newer classification schemes group them in 3 categories. The first one are the provisioning services, which are the products that we derive from ecosystems. For example, fibers such as timber, the water provision, fruit production or crop yields. And of course, these are just examples, as you see. The second category are the regulating services, which are the benefits that we obtain from the regulating capacity of ecosystems. So for example, ecosystems protect us before floods. Then climate regulation, as you all know, air quality regulation, or for example, the maintenance of soil fertility. The last category are the cultural services, and these are the non-material benefits that we obtain from ecosystems, such as the tourist attraction or just the existence of a beautiful landscape. Older classification schemes had a 4th category, which were the supporting services, but now these are seen as underlying to these 3 categories. So now we don't, in newer classification schemes, we do not anymore have this category. And I said that's just examples that I put here, but that's like an overview. If you have a detailed look at the classification, it might look like that. So that's actually the CICES classification, and you see, I have to point with that, I know. You see here the 3 categories, the provisioning, the regulating, and the cultural services, and actually then they are grouped up. For example, here you have the provisioning services, here is actually nutrition, biomass, and the first one is cultivated crops. And here you have crops by amount and type. So these are actually all the crop types that you can imagine. So, and the entire table is that detailed, so you can imagine that there are quite a lot of ecosystem services. I'm just showing you that to tell you that there is not a bunch of 20 services that we have defined as ecosystem services. Actually, any benefit that we derive from an ecosystem is an ecosystem service. And it completely depends on the classification in which one of these categories you put them. But you can't say there's a bunch of 20 or a bunch of 100. You see that? Okay. So moving on, the concept is actually a clearly anthropocentric one. So without a benefit for the society, there's actually no service. Some words about the development. Throughout the entire human history, there have been individual people that recognized that ecosystems provide some benefits to mankind. The first one might have been Plato, already 400 BC. From the 1960s on, when we had an increasing effect on our ecosystems, there were more studies on the relationship between ecosystems and the human welfare. And one milestone paper clearly was the Constanza paper in 1997, where actually the value of the world's ecosystems and their natural capital was assessed, and there was a global map plotted where ecosystems were given in monetary values. In 2005, the Millennium Ecosystem Assessment significantly contributed in bringing that concept forward on the political agenda. And also in this assessment report, it was assessed that about 60% of the world's ecosystem services are degraded to a certain extent, and with large changes here having happened in the last 50 years. In 2010, The Economics of Ecosystems and Biodiversity, that is also a report, was published, and that put the attention to the economic benefits of healthy ecosystems. So it was actually made clear that we have an economic benefit if we invest in biodiversity and ecosystems. So today there's actually a exponential trend in the published articles, and that was just a quick search. In the last year there were published over 5,000 articles on ecosystem services. So the ecosystem service concept links the ecosystems from which the services are derived and the people who depend on these services. So we have a certain supply and a demand for services. And the supply is actually the capacity of a region to provide a bundle of services. And it's, of course, depending on the biophysical conditions of this region and about the ecological integrity, meaning how intact is this ecosystem and how much anthropogenic impact is there. And then the demand is the desired level of provision of this service by the society, and it's mainly governed by the population and the economy, but also like social trends and habits, for example. And the ecosystem services are actually in between and with this supply and this demand. So how does this concept help us? As you can imagine, or as you probably know very well, we have increasing environmental and economic pressures on our ecosystems. First, that's climate change, then economic things like increasing population or the economic growth that we always want to maximize our gains. And that puts increasing threats on the ecosystems and also on their functioning. And so we really expect that in future we do have more ecosystem use conflicts. And for this is a useful link. This concept provides a useful link between ecosystem functioning and the society. And because of these threats, we do need a concept like this. So actually, the assessment of ecosystem services raises the awareness of the benefits that we do derive from nature. Then it may support the development of policies and instruments that can integrate these three perspectives, which are the social, the economic, and the ecological. And then it also helps to inform decision makers, because knowledge alone is not everything. We have to transfer the concept into policies. And the concept may help to inform decision makers so that this concept can actually be incorporated in the decision-making processes. So to give you an example on the ecosystem services that a region provides for us, I didn't go very far. Actually, I just went outside this institute. So if you go just outside the house and have a look a bit in this direction, and if you wait 2 months so that the snow is actually gone, you might have this view. So you see the Zugspitze and a meadow just in front of it. So what does this landscape actually provide for us? The forest, starting with the forest, as you know, it stores carbon, so it provides local and also global climate regulation. It prevents the slopes and also the nutrients from being eroded. Together with the meadow, it maintains the genetic diversity of the plants. It maintains soil fertility, regulates water flows. The meadow itself provides raw materials and food and fodder, because sometimes they have small sheep there or also goats. It provides genetic resources and is a source for pollination. Then the landscape itself is a source for inspiration, for culture, art and design, actually the aesthetic enjoyment, and as you may have noticed, Garmisch has a lot of tourists. So it's actually also the tourists that come because of this landscape. Then the mountains contribute to air quality regulation, and the glaciers themselves provide the water. So this is actually quite a number of services, and if you imagine the long list of services, this is definitely not everything that this landscape provides to us. But these are some examples that I think you can easily see how it contributes. So in the context of ecosystem services, one question that is really frequently asked is the link to biodiversity. How does biodiversity link with the concept of ecosystem services? As you saw from the first classification, biodiversity is not a service itself, but it definitely underpins a number of services. So if you do an ecosystem service assessment, biodiversity is very often assessed together with ecosystem services. But it's good to keep in mind that biodiversity is by definition not a service itself. Also for biodiversity, you expect a continuing trend in decline in biodiversity. And of course, this decline will also affect the flow of ecosystem services, but which is more important, it will also affect the resilience of the ecosystems to future changes. Because if an ecosystem is resilient to a change or not, majorly depends on the variety of plants that is in this ecosystem. We do acknowledge that there are links between biodiversity and ecosystem services. However, these are complex, and they are for some ecosystems they are better understood, for some they are not so well understood. But at least there exist some examples where management options have been implemented that have a favorable outcomes for both ecosystem services and biodiversity. And this is of course because of that links. So if we talk about ecosystem service assessments in terms of how do I quantify my ecosystem services? Ecosystem services usually are flows. So they are a change in a stock over a time, so a quantity per time unit. For example, an amount of crop yield per hectare per year. And usually the stock is just underlying this flow. So it provides the basis for this flow. But the flow itself is the service, which is very important. Assessments are place and time specific. You can, for example, do an assessment just for one location. For example, if you go outside and assess these services of the meadow, that is one space, one time. Very often they are provided as aerial averages or totals, for example, national statistics, crop yields per country, something like that. Or you do that on a regular distance. Anything that we do with modeling is on gridded data, and that's another possibility to provide ecosystem services. What you normally derive is a state of an ecosystem service, so a snapshot of a service condition at a given place and time. And in addition to that, you can also analyze trends, which is this change in the state over time. But you have to discriminate what you actually assess. What is very important in these ecosystem service assessment is the variation of the service over space and time. For example, a simple example, if you think of agricultural production, then the freshwater provision in actually the driest month would be the limiting factor. It would not be the average over the entire year, but because if there's 1 month where it's extremely dry, then your entire crops die. So it's very important to know about the variation of the service over time and not just averages. And of course, as every assessment, an assessed quantity should be accompanied by a confidence measure. And what you will just see now from the following examples, there's a lack of a consistent methodology to quantify ecosystem services. But this is also a consequence of the sheer variety of services. And you can imagine that not with every method you can quantify every service. So now there are some ecosystem service quantification methods. The most straightforward one is based on primary data. That's very often based on available national or global statistics, for example, the FAO statistics, which are national statistics brought together so that they are global statistics. Of course, they are very helpful and are very straightforward because you can have an assessment in a short period of time if you just go to the FAO stats website. But of course, that can't be for every, that is not available for every ecosystem service. A second idea of primary data collection would be if you do measurements outside and if you really assess, for example, soil fertility by measuring it. But as you can see, and if anyone did a PhD or a doctoral thesis where you did these measurements, then you know that they can be quite labor intensive. So primary data is potentially the most accurate way, but depending on the resources and the services that you want to assess, it can be quite resource intensive. Another possibility how to quantify ecosystem services is by indicators or proxies. Usually these are some quantitative biophysical variables that have some logical connections to the service that you want to assess. So, and of course, the proxy should be easier to measure than the service itself. That's why you take the proxy, right? So very often plant traits, for example, are used for that. Very often land use like the Corinna land use cover or global land cover. or vegetation indices like NDVI or something. And then, based on the indicator, for example, land use, the final service is then assigned via a lookup table. And the lookup table is built based on measurements, for example, in specific biomes or land use categories, or based on expert knowledge. Everything is done. So that's an example where for a region in the middle of Germany, based on Corinne land use cover data, here quite many categories, they map the food provision. And that's done via a simple lookup table between this yellow land cover class and the food provision. So this is very helpful indeed, but it's depending on what you choose. For example, plant traits data might only be available on smaller scales, while land use data are usually also available on larger scales. And the degree of validity of your assessment definitely depends on the data you're underlying. And normally these indicator methods are just valuable for large areas. A third possibility how you can quantify ecosystem services might be via models. And I guess if you are here, many of you know or are familiar with types of models, and you know that there's a sheer variety of models out there. Some are statistical models, some are socioeconomic models, and then we do have the process-based models. Some of them are empirical models, some of them are validated, some are not. So depending on the model you use, also your result is valid or not. That's an example that is very close to what you want to do in the exercise today. So that's with a dynamic process-based model. You know that you have the environmental drivers based on which the model actually works. Then you model your ecosystem processes like photosynthesis, the respiration. You get your ecosystem state variables like NPP, the runoff, the carbon storage. And based on these state variables, you can quantify services. But as you can imagine, you can do that for some services very good, for example, carbon sequestration, food supply, or water supply, because they directly relate to these ecosystem state variables. But for example, that would not work if you want to assess cultural services. So also here, different types of methods are needed for different services. After we talked about these three methods that can quantify the supply of services, we also have to talk about the demand for services. But that can actually be quantified with very similar methods. So for example, it can be quantified based on statistics. For example, how much timber is produced per year, because that actually quantifies the demand for a service. Then you can also do that based on modeling, which is actually more socioeconomic modeling. And then also via monitoring and interviews. For example, people are actually asked, how much would you want to be provided of that good? Or, for example, of a cultural good or something. So the demand of services is actually quantified very similar to the supply of services. So based on a review that is supposed to come out in this year, I wrote down the current practice in ecosystem service quantification. So very often the research focuses on the supply side. About more than 70% of the studies actually quantify the ecosystem service supply, but the demand side is not very often included in the research. Then, as you can imagine, there are some ecosystem services that are quite frequently mapped. For example, climate regulation, the food provision, recreation also. While other services are clearly underrepresented. And of course, that are the ones that are hard to quantify. For example, ornamental species, biochemical products. In terms of quantification approaches, we have a clear lack of using primary data. Only about 35% of the studies use primary data. Other approaches, of course, modeling, then the lookup tables, and also a lot of reviews come out. So ecosystem services are basically quantified based on the assessments of other persons. In terms of approaches, the proxies and the lookup tables are definitely the favored tool. That's more than 50% doing that based on mainly land cover. And there's an increasing use of models over the last year. statistical models, also process-based models. But in combination to modeling, we have to say that very few studies do provide an uncertainty assessment. So more than 70% do not provide a validation or an uncertainty analysis. Usually the evaluation of the current state of a service is evaluated, more than 70%, and there's a clear lag in the consideration of future changes, for example, socio-economic scenarios like policy directions, what would be the effect of a policy, or also climate scenarios. So the modeling community is very far in using climate scenarios, but the ecosystem service community not yet. And then just about 30% of the studies consider relationship between services. Others assess different services and report the quantities. And as you saw that the quantification approaches are quite diverse, there's a call for a consistent methodology, how ecosystem services should be assessed in given contexts. And these are actually called blueprint protocols. So after we talked about the quantification of ecosystem services, then we also have to acknowledge the other side of the concept, which is the economic side. And here one question is, should we put a price tag on our ecosystems? So maybe, why should we put a value on them? So as you said correctly, I would also say to communicate the importance of the services in a policy environment, because that is quite greatly facilitated if it is accompanied by a credible economic value. The world speaks money. So to communicate the importance of services, we can put a price tag on services. Then it's helpful to estimate the costs and the benefits of an action, to put that into monetary terms, what we would gain or what would we lose if we lose this service. Sorry. Then it can also enable the more efficient use of limited funds, of course, and it facilitates effective policy incentives of fines or setting taxes, for example, that fee that we have here on our oil, or for example, fees if you pollute or a national park or something like that. The contrary, why should we not put a value on ecosystem services? And of course, the overarching argument here is it is something that is priceless to us, and we should or we can't put a value on that. And actually, the ecosystems for us are something essential, and we don't have a substitute for it. So when our ecosystems are gone, what shall we do? We can't say, okay, yeah, they are gone, but we have so much money, can we get them back? Okay, so can we value the priceless? And finally, as you also said, in terms of methods, it's very hard. How can you put a price tag on it? Would it be feasible to derive a value that would be okay for this plant or for this tree? Would that be related to that stakeholder or that stakeholder? Or maybe the price is a complete different one. If you think of an economist, for example in the States, in Europe, no matter, the money that he would have available to buy that tree, for example, is a completely different one that if you think of a farmer in Africa. This farmer, for example, lives on this patch of land, and this patch of land provides everything that he has and everything that he needs to feed his family. And then some economist would just say, well, I have more money than you have, and if you say this patch of land is $10, I can pay it. But for this farmer, this patch of land is invaluable. So how can you actually quantify that? And that's really one hard argument that you can put on the side not valuing that services, because can you do it on a fair basis? I don't know. So maybe we can summarize that by saying monetary valuation can really be helpful. It can inform decision makers on the full social costs and benefits of healthy ecosystems. So that's everything what you said of making people aware, putting a price on making people aware on it and bringing the costs and benefits into play. But maybe it should not be that on sale sign. It should not be, we have a price there and you can buy it. It should be in a context. So maybe you should say, okay, we value this ecosystem, but we do that in this and that context, and that is what we incorporated on getting that price. And that price is valuable just for this specific question. And finally, of course, just by putting a price on these, it doesn't mean that you necessarily have to trade it. What happens with carbon credits is also actually just a policy measure to bring carbon sequestration forward. But that doesn't mean then some economists have to trade that forest against that. Okay? And finally, in all that discussion, we should always keep in mind that in daily decision making, we actually explicitly or implicitly already put a price tag on ecosystems. I mean, if you just think of what you buy in a supermarket, a lot of them are actually ecosystem services. That's what ecosystems provide for you as a product. So actually, you do already trade them. And you also do put a price on it. For example, if you say, okay, we need tires for our cars, so we need some rubber plantations where actually tropical forest is supposed to grow. So you see that there's always a trade-off between we are consuming, we are living in a certain luxury, but that always has an effect on ecosystems. So also if you say, no, we should better not put a price tag on services, you should be aware that in some circumstances we actually already do that. So the economic value of a service is actually the quantity of the service per unit time times the average market price. And actually the quantity of the service per unit time, that is what we assessed in the ecosystem service quantification. So now I will give you some examples on how you can quantify the average market price. And these economic valuation methods, they are direct market valuation methods. And of course that is just for the services that are actually traded on a market. So for example, for water or timber or crops, you can take the direct market prices for these services. Then other services are actually, they contribute to the production of a good. And that's how you quantify to which degree that service contributes to the production of the good. For example, shrimp production around mangroves. How much do the mangroves contribute to that shrimp production? And this value you give these mangroves. Another option would be cost-based approaches. For example, the cost of actions to avoid damages, to provide substitutes. For example, wetlands provide flood protection to us. So what would we have to pay if the wetlands would disappear and if we would have to provide this flood protection by building dams? That is the value that you would assign to these wetlands. Then there are indirect market valuation techniques. The most important one is hedonic pricing. The most given example is just you have a house, and one house is same house, and one time it stands away from the coast and one time it is at the coast. And of course, or normally, you will get more, the house at the coast has a higher value than the one that is apart from it. And that's actually the price of this view. So that's hedonic pricing, and the travel cost method is very similar. How much are people willing to pay to drive, for example, to a national park, to a recreation area, something like that. Then there are non-market valuation methods, and of course that's more used for the goods that are not traded in markets. These are the stated preference methods, and in there people are, for example, asked how much would you be willing to pay for this good? Or which situation change would you prefer? And based on that, one service is graded over the other, and finally there's a price assigned to this service. In addition to these first order valuation methods, there are also like secondary methods where you take existing values and transfer them. For example, you do a meta-analysis and then transfer the value that you get for one service in one environment, in one region, you just transfer it to another region, and that's value transfer. So this is an example. That's actually the Constanza paper, so the maybe first map where the monetary value of ecosystems was mapped for the globe. And you see the prices go up to 10,000 international dollars. Based on that map, they calculated a total value of ecosystem services in 1995, and that was $33 trillion US. Then they provided an update in 2014, last year, where they said it's $125 trillion. And you see I calibrated that. That was calibrated to the US dollar value in 2007. So the first estimate was 46 and the second one was 125. And actually they used the same methods to quantify these numbers, but in the second time it was quantified for the status of 2011, and it was quantified using updated data on in particular land use. So you see that they are there's a certain variety. That's a second example on the economic value of ecosystem services from 2012, where the ecosystem service value of major biomes has been estimated, and that they did that not based on primary data, but based on 320 publications. So they had over 600 value estimates and did a compilation of 22 services. And you see that the tropical forest, we have quite broad categories. So we have tropical forests, temperate forests, woodlands, grasslands, and marine ecosystem services. And you see that in this grouping, the tropical forests are quite the maximum, with around 5,000 international dollars per hectare and per year. So if you would split up these categories a bit more and go from this broad classification to a more detailed one, for example, classify coral reefs and wetlands as singular categories, your picture is a quite different one. If you pay attention to the scale, if you pay attention to the scale, you have here the tropical forests, which are 5,000 international dollars, and now we have for the coral reefs around 300,000 international dollars per year. So that shows you very much that it's also depending on the classification. And here the difference is just that wetlands and coral reefs provide a number of services, regulating services, which is the red bars, but also cultural services and provisioning services, and so they are kind of invaluable in comparison to a patch of forest. So these two examples just show you that the value estimates strongly depend on the applied methods, on the included ecosystem services, the definition of regions, if you have broad regions and average over large regions, or if you have really detailed regions such as coral reefs or wetlands, and also on the time frames. And an outcome also of this second study was that most of the value of ecosystem services is traded outside the markets. So they are actually not traded. Coral reefs are not sold. And also the value of coral reefs is not sold. So finishing up with the economic valuation, if you would do a quantification study of ecosystem services and you are quite skilled and motivated, and you do the assessment of a quantity of one ecosystem service and say, okay, we have this quantity. And because you are very motivated, you don't do that just for one service, but you do that for a bunch of services. And then you know your quantities of the services A, B, C, D. Then you actually did what most of people do. They analyze a bundle of services to answer a particular question or problem. And that's actually what around 50% of the recent studies do. But the question after that is, do you see the whole picture? What does that information provide you? Is that now much what you provide in one category, or how is that related to the other? So actually this picture would look more like that. So it might be that, now I have to use the mouse, it might be that you have areas where two services are intersecting and you actually have just one service but not the other at the same point. Then one service, for example this round thing, might be much larger than other services which you haven't seen before. So the relation of this one to another one is quite different. Then some services might add up to different shapes. So they actually provide a shape that you haven't seen before. So you see that the picture is quite a bit more complex, and that we need to consider the relationship between these shapes, but they are equivalent to our services. So to see all the interconnection between the economy, the ecology, the environment, and the society, we need to do a trade-off analysis. So that's now when we talk about trade-offs and synergies between ecosystem services. And I'll just give you here a brief introduction, and I said we do the examples tomorrow after you did your exercise. So ecosystem services are not independent of each other. Trade-offs occur when the provision of one service is reduced as a consequence of the increase of another service. That gives the trade-offs. One goes up, the other one goes down. A synergy is a positive effect. For example, if I increase one service, like if I increase biodiversity, then also other services would increase, although I know biodiversity is not a service. But because trade-offs occur, bless you, because trade-offs occur like 3 times more often than synergies occur, we very often leave the synergies out and just talk about trade-offs. When we talk about the relationship between ecosystem services, we say trade-off analysis. So the causes of trade-offs are just because ecosystem services compete for space. You can either have a forest there or you can have a cropland there. And they are causally linked. So for example, if you have an intensive agriculture, you can imagine that this provides a lot of crop yields for you, but you can also imagine that at some point it reduces the soil fertility to a certain degree. So there is a causal link between services. Most trade-offs arise from management choices made by humans. Some are explicit choice. If you say, I need this plantation here instead of the forest. Some are also unintentional. So we are just not aware what is linked to what. And that is the thing, that we need more information to understand what are the linkages. What do I change if I actually focus on this service? What do I change in the other services? So that's actually why we should care. Ignoring the interaction creates unanticipated consequences and also conflicts between the services. And of course that's the basis to make sound decisions. And we said that we have increasing pressures, and of course with these pressures also the trade-offs between the services are expected to increase. And also the interaction between services might lead to non-linear effects and also tipping point. You can imagine if I always decrease the soil fertility, then at some point you might come to a point where you can actually plant no longer any crops there. You can, for a certain time, you can fertilizer application is of use to you, but at some point the system is just so degraded so that you can't actually plant anything else. And this is called a tipping point. That's like if you can't, like a point of no return, if you want like that. So the last one actually, trade-offs exist over different dimensions, for example between services. For example, cleaning a forest for agriculture, you can either have the forest or the agriculture. They exist over time, for example a short-term focus on agriculture, the long-term loss in soil fertility. Then of course over space, if you compare the services of different regions over the globe. Between users and stakeholders. For example, if you use the water for drinking, or if someone wants to use it for cropland irrigation, how would you assess this one is better than the other? And then also between alternative management interventions. And so that I would actually do a wrap up here and release you to your practical exercise. We talked about ecosystem services, and they are defined as being the benefits of the benefits that people derive from ecosystems. The concept helps us because it raises the awareness for what ecosystems provide to us, and it's to support decision makers. Ecosystem service assessments, we said that services are actually quantity flows. They are specific in time and space, and that we have many, many methods out there, but the preferred method is doing that via proxies or indicators, for example the land use. The economic valuation of ecosystem services, you saw that already here in this group we could have a vivid discussion on if we should do it or if we should not do it. It might be a helpful tool in a policy context, but we should be a bit careful and not just put it on sale on it. And finally, the trade-offs, we saw that the relationship between ecosystem services is actually needed to see the interrelations between the services. So that would be actually everything for today.